the most famous, most used, because it's the only one, dataset, public dataset around the world. It's called DARPA 1999. We were testing with this dataset also previously Poseidon, so we use it the same just to show that this approach is better than the previous. Like Poseidon was achieving 100% detection rate and some false positive. Sphinx is achieving again 100% detection rate and with 0 false positive. Okay, this is really a stupid data set. Unfortunately, the world is not able to sit down, think, and come out with something new that will reflect the 2007 data traffic. So, yeah, it was easy. And now let's go for something serious. Again, in our research, we applied, we were making experiments and we collected the private data set in our university. Well, you would really be surprised what the people in the university is doing, but it was full of everything. Like they were requesting MP3. This was our department main site. So our shop window out of the world. The world was coming to see what we were doing. So there were MP3 files, PDF files, porn movies, and so on. So there was it was really garbage. You could really find garbage out there. This website has something like 1,000 requests per hour. And we have found evidence of SQL injection and cross-site scripting attacks that were manually crafted, by the way. There were some buffer overflows and a lot of scan attempts for well-known paths like, my PHP admin and something like this. By the way, for example, Snort on this data didn't find anything. The latest rule set of Snort didn't find anything. So, with our previous system, we were able to, when we were achieving the 100% detection rate, that it's always possible with an anomaly detection system, you just raise the threshold, you just lower down the threshold as much as possible. We were getting a total of 2.85% of alerts. That is quite a lot if you consider that we had 1,000 requests per hour. That means that a lot of times the web administrator was going there and say, oh my God, what is now? Oh my God, what is now? With the new system, we were able to achieve 0.2% of false positive. I personally believe that this is, if you do the same cleaning if you apply the same cleaning data set also for this is not gonna lower down too much. So I believe that this is because the three analysis techniques combined together are really working. It's not just because we were cleaning the data set in that automatic way, for example. Because somebody was asking me before, well, maybe it's because you were cleaning it. Okay, we cleaned it also for this and it didn't work. Now, the really cool stuff, for me at least. Okay, maybe you have seen that there are somebody saying, okay, my anomaly-based intrusion detection system can also provide for you the signature. So once it has discovered the zero-day attack, it will provide for you the signature. Okay, this is true. I mean, the system will generate the signature. What are you going to do with the signature? It's unknown. I mean, it's not working. If you see some system also like provided by the academy world, they are completely useless. I mean, okay, yeah, the attack was correctly flagged as an attack, but the signature that they come out with, completely useless. And you cannot rely if you are deploying your own web application system because you are a bank or whatever you are, a merchant, eBay, whatever. They have all their own web applications. So the signature of Snort are not working because they are general. They are for other stuff. So you have to spend a lot of time in writing your own signatures if you want to catch the bad guys. So, first of all, we are not generating signatures from the attacks that we have detected, but we are generating signatures for what is allowed to pass. So, once our system has learned what is allowed to pass during the training phase, it's producing the signatures for the numerical values and most of the short text parameter in the format suitable for mod security. So, for example, this is the signature automatically produced for the ID parameter. Or we have func here, and we add delete and view. So, in this case, for example, we are accepting only these kind of values. So we are like reverting completely the normal meaning of signatures. Instead of catching what I know is bad, I'm rejecting everything that I know, that I'm accepting only what I know is good. This is like a firewall kind of orientation. Okay. This is the signature generated by our system. This is the same signature of mod security that is commonly packaged for you in the rules. They are doing exactly the same thing. You will get exactly the same. Now, maybe with this one you're losing something. So here you will see a command shell file list. So they are trying to catching actually SQL injection. With this, you are accepting only numbers for that parameter. And you know that there must be only numbers there. Okay, now I have a short demo. It's really short because the time is really tight. So, in the very origin of this project, this had to be an automatic generator of signatures for mod security, for the short text and the numerical field. So we just said, okay, let's write it in Java. It will be a nice script that we can run and so on. Here I have two logs files that a good friend of mine gave me for this purpose because my university didn't allow me to bring the one that I made the experiment on. So if we look at them, they are from post-nuke installation. So you can see the normal post-nuke request like this one, and so this guy wanted to see index, news, the language was Italian. What more? Then, like for example, here there was the browser and so on. So, normal stuff that anybody installing post-nuke will have on his website, on his web server. Now, we run. It's finished because it's only 1 megabytes. And here we have the rule. So, for example, here we are saying that, for example, we are setting only ET, Italian, Deutsch, English, and French. Nothing else more. Or, for example, here we are accepting only page head, that it's a module for post-nuke, archives, and news. And we have analyzed 1,960 samples. The first one is new lang, ITA or English, Italian or English. 2,279 samples. If we go down, these are all the signatures for the numerical parameters. So, for example, well, these one are really few, but this one is 912 times. So, in less than what? 5 seconds, this website is protected. On this website, nothing is going to enter anymore. Okay. We're running really out of time. Okay. It's time to finish, and especially for the question. So, this is the first totally automated, anomaly-based solution that the Academy has produced, and I hope the word. Which are the main features? So we are inferring the parameter type, observing the data as they come. So we have these three basic types: the numerical, the short text, and the raw data, or long text, whatever you want to call it. And we use different models, not at the same time on each parameter, but for each parameter we identify the type and we use just one model on it. The best thing is that we can generate the signatures in an automatic way, as you just saw, for what is allowed to pass. So we're not generating signatures for what is bad, we're generating signatures for what is good. In this way, you can acquire like a third-party model and just plug in this. The users are starting to use it, and you will have immediately the signatures for mod security to have your system protect without wasting time with your IT specialist getting a very bad headache and so on. What we cannot catch, why this is not the silver bullet. If you were here this morning at the David Maynard presentation, then you should have understand that, for example, the attack that he made is simply like he was able to dump the cookie session, the session number of a user, like using any webmail, like Google Mail, and then he was able to use the same number to get in again when the user was not in. That is an attack to the logic of the application. We cannot catch something like this because everything that the guy was passing today was legal. There was nothing, there was not a buffer overflow, there was no injection of anything, just what is legal. It was observed before, the system knew how to generalize it, even with, there was no way, any intrusion detection system would detect that, because it's an attack to the logic of the application. So this is something that is lacking, and unfortunately I believe that the only way to do that is to programming in a better way or to write smarter programs to check. But anyhow, the programs are already show that they are not good enough in analyzing the source code and find out what is wrong. What we are doing right now is, okay, we developed blah, 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 everything is okay, but we want to test it in real environment. So luckily, in my user committee, there is a Dutch security outsourcer, and they really like it. So they would like to, they want to put it in their customer site, or at least they want to use it to analyze what is coming back from their customers. And so these days we are making the final agreements, the final papers, and so on, because we want to see how the system behaves in the online, when the system is going online. So that means operating real time. They have e-commerce sites and banks also, so it's good platform to test, because it's what the world is doing. We're not just looking at personal pages on a website. So this is it. I don't know if you know that the Sphinx in the past, in the Greek mythologies, was a lion or something like this, waiting people before the city, before a Greek city, and she was asking a question to them, and if they were not able to answer, she was killing him or her. So I don't want you to kill me, but now is the question time. So